Class, we're moving on to problem 6.88. The skid steel loader has a mass of 1.18 megagrams, and in the position shown, the center of mass is at G1. If there is a 300 kilogram stone in the bucket, with center of mass reactions of each pair of wheels, A and B, on the ground, and the force in the hydraulic cylinder, CD, and at pin E. There is a similar linkage on each side of the loader. Eleanor, find the solution. Yes, Professor.
Alright, so first we're going to examine the body as a whole and to determine the support reactions in the wheels of the backhoe, so at points A and B. So we're going to start out by summing the moments around point A. So we'll multiply force of B times the distance between A and B, and then we'll subtract the mass of the backhoe from that number, multiply it by gravity, and also by the distance from point A, and then we'll add the mass of the load in the backhoe, multiply that times gravity and the distance from A, and that will give us 3,371 newtons for the reaction force in B. Next we're going to sum the forces in the y direction, which will give us the force of A, which is going to equal 11,133 newtons. So that gives us the support reactions. Next we're going to explode the diagram into two parts. This is the main part that we need. So this is just the arm that's holding the load. So we have point E here, we have the two-force member, and then we have the load, and this force CD is acting at a 30-degree angle to the arm. So our third step is to sum the moments around point E, which will give us so we'll multiply gravity by the mass of the load times the distance to point E, and then we'll subtract the force of the two-force member, multiply that by sine of 30 to get the y component, and multiply it by the distance, and then we're also going to multiply it by 2 because we're only examining half of the system since it's a vehicle. So solving all that will give us the force of the two-force member, which will be 6,500 newtons. Our fourth step will be to sum the components in the x direction, which will give us the x component of pin E, which is going to equal 5,607 newtons. Our fifth step is going to be to sum the components in the y direction, which will give us EY, which is going to equal negative 1,766 newtons. We have to divide it by 1/2 for the same reason that we multiplied it by 1/2 up here, because it's split in two. And our final step is going to be to solve the resultant force of E, which is going to equal
5,789 newtons.
Good job.
F equals 5,879 newtons.